Hi everybody, today we're going to talk about something called hypothesis testing. We'll just introduce the idea today and then we'll continue to address it throughout the rest of this series. So of course a hypothesis needs to be defined first. If you recall the scientific method usually starts out with some kind of theory. A theory is just an idea of how things work or might work, right? And it could be really anything, that's fine. There are some bad theories and some good theories. I'm not going to get too much into that for this particular lecture. You can read my textbook if you want to know more about that. But once we have some kind of theory, then we can come up with hypotheses. Hypotheses is the plural word for hypothesis. Hypothesis is the singular. A hypothesis is some kind of statement as to what we should expect to see if our theory is correct. In other words, if I were to come up with some observations, some controlled observations to test my theory, what should I see happen? Okay, for example, let's say that I have a theory like exposure therapy reduces anxiety. Something about exposure therapy, and my theory would probably go into detail as to why this happens, and there are some good theories about this, but let's say exposure therapy reduces anxiety is my theory. That's an idea of an explanation of a relationship. Now, my hypothesis could be something like people who engage in exposure therapy will have decreased anxiety compared to controls, meaning people who are not getting exposure therapy, people who are getting some other kind of treatment probably. Okay, so that's what a hypothesis is. Now, this is all important for statistics because this is essentially the testing portion of a statistical test. The test of a statistical test is that we're testing which hypothesis is correct. Okay, so let me give you a goofy example to help make this make sense, make this relatable. So let's say that you've got some guy named Timmy, and Timmy's kind of got a crush on Sally. He wants to ask her on a date, but he doesn't know if she likes him back. So imagine that. There are basically two possibilities here, is that she does like him and she would say yes, or she doesn't like him and she would say no. And he doesn't want to go through the embarrassment, so he doesn't want to ask her if he thinks that she would say no. And so what he needs to do is sort of figure out which one of these is more likely. And sort of internally, maybe he says to himself, well, you know what, I'm going to wait until I get to a sense of surety that's about 70% sure that she would say yes. Okay. Now, does he need to get to 100%? Sometimes you can get there, right? Sometimes the flirting's clear enough that she really likes you and she makes it pretty obvious. And sometimes it's more like she definitely doesn't like you, right? She can make that clear obviously as well. But in a lot of social relationships, it's a little less clear. There's sort of it seems like she likes me kind of thing. And so maybe that's what Timmy does, is he kind of gets to this internal sense of 70% surety that she would say yes, right? And now that's kind of risky though, because there's still the 30% chance that she would say no. And this happens all the time, right? You kind of think, yeah, I bet she'd say yes. And then it's like, oh yeah, I'm already involved with somebody, or not really interested. I think we're better friends, things like that. And so he doesn't want that, but he's willing to take the 30% risk of a no if he's got the 70% surety of a yes, right? So what he does is he makes careful observations. He interacts with her over a few weeks, maybe a few days, and kind of gets to this sense of where are we? And until he's relatively confident that it's about 70%, he just doesn't do anything, right? Okay, so what does this have to do with statistics? Statistical tests kind of do something like this. Of course, it's not always in relationships, however. But what they do is they look at two possibilities, at least two, and they say which one of these is most likely. Although it's a little less than that, it's how likely is it that my hypothesis is correct? How likely is it that my hypothesis, the threshold for my hypothesis, has been met in this condition? Now, this will make more sense as we get into more tests, but I'll continue to talk about it a little bit more. So let me tell you the two different hypotheses that we have. Sometimes they're kind of more than just two. There are different versions of some, but this is all you really need to know at this point. The first hypothesis is called the null hypothesis. I'll explain why it's called null hypothesis in a second. It's our default hypothesis. It's the one that we assume is true unless we have good evidence or strong evidence that would suggest otherwise. And again, this makes sense, a little more sense later. The null hypothesis essentially just states that there's no impact of one variable on another variable. Okay, now if you think about that, that means that we're approaching it to start off as very conservative, right? We are very hesitant to jump to conclusions, and we'll just assume that there's nothing related to anything else for now. because we don't have clear evidence that it is. But once we do have clear evidence, then we'll go for it, right? In this case, it's conservative. Now, in statistics, there are some tests that are more conservative and some tests that are more liberal, we could say. But our null hypothesis is generally this, and we treat it as true until we have sufficient reason to suggest otherwise. Now, this is the symbol for the null hypothesis. In this particular one, this is the null hypothesis for a mean comparison of just two means. I'll talk about that here in just a second. Let's start with this, though. So the H means hypothesis. That just stands for hypothesis. This 0 here is the null, right? Null is, of course, 0. That's why we call this the null hypothesis. It's the default, the start-off hypothesis is why that essentially began. And then we use the colon here to demonstrate what this is. And what it essentially says is that the mean of group 1 is no different from the mean of group 2. Now, in a mean comparison, that should maybe make sense. That'll make more sense, I think, as we talk about the t-test. But think about that. So if there's no impact of a variable on anything, then you really should expect the mean of one group to not be any different from the mean of the second group if you treated them essentially the same otherwise without the impact of the independent variable. Okay, so that's the null hypothesis in a nutshell. Don't worry, though, we'll continue to talk about this for the rest of this series. Now, there's also another hypothesis. So we sort of start off with this null hypothesis. Maybe that's like Timmy saying, you know, I'm just going to assume Sally doesn't like me. That way I don't get disappointed if I'm wrong and I say she does like me and then I get embarrassed in front of people or something like that. So I'll just kind of have this default hypothesis that she doesn't like me. But if I have, you know, reason to believe otherwise, then I'll go ahead and ask her out, right? So that's the second possibility, is that she does like him and he just needs enough evidence to demonstrate that, right? So that is the alternative hypothesis. Now, and some tests have more than one alternative hypothesis. I'll get into that later. But right now, the alternative hypothesis suggests that there was some influence of the independent variable on the dependent variable. Okay, so we call it the alternative hypothesis. And in a mean comparison, so in other words, in like a t-test, which we haven't really talked about yet, but we'll get into, it looks something like this, right? So again, we have H for hypothesis, A, of course, meaning alternative, and then the colon meaning this is what the hypothesis is. And in this case, we're saying that the means are not the same, right? You can see it says that they're not equal. In other words, there's something different going on here. Maybe we can't quantify it exactly, but the mean of group 1 is not the same as the mean of group 2, right? So in other words, that would be like maybe Timmy goes, this is sort of a rough estimation, but Timmy goes and he can tell that she's being very receptive to his phone calls or something. She laughs at all his jokes. She's initiated physical contact, just kind of pats his shoulder or whatever when he tells a silly joke or something. And he's starting to go, you know what, there's something going on here. Now, if there's enough of that, then he can say, I don't think my default hypothesis is true. I don't think that she doesn't like me anymore, if you'll excuse the grammar. And therefore, he can say, I think that she does like me. And now he gets to a point maybe where he says, okay, it's more likely that she likes me than she doesn't. Okay. So it's important to note here that the null and alternative hypotheses will be different depending on the type of test. So that's why I'm going to go over it for every test that we go over now. These that I've covered just look like this for mean comparisons, specifically when you have only two means. So don't worry about that. But the HO and HA will always be the same in and of themselves. It's just what the symbols will be afterwards. And it's important to note that the null hypothesis always means that there's no effect of the independent variable on the dependent variable, or you could just think of it also as there's no effect of any variable on anything else, right? That's the most conservative kind of position you can have in this kind of statistical thing. And then the alternative is always that there is an effect. Sometimes you can specify where the effect is or what direction it goes or things like that, but the alternative suggests that there is an effect, okay? All right. Now, some important things also, you may be able to connect this with some earlier topics we had with the type 1 and type 2 errors. The type 1 error, of course, is when you have a false positive. So in other words, if you incorrectly reject the null hypothesis, in other words, if you kind of say, okay, I can just assume that I can get rid of the idea that she doesn't like me. If you're wrong, you just committed a type 1 error in Timmy's example. So that is the definition of a type 1 error. And then if you incorrectly retain the null hypothesis, in other words, you incorrectly say she doesn't like me, but in reality she really does, that's called a type 2 error. An incorrect retention of the null hypothesis is the definition of a type 2 error. Okay, there's a lot more, but let's stop there. So once again, a recap, the statistical tests tell us the likelihood that an independent variable has an effect on the dependent variable. And we start off with the assumption that there is no effect, but if we get strong evidence that there is an effect, then we can go ahead and relatively safely reject our null hypothesis or overturn our null hypothesis, if you like that term. So then if there is an effect, we accept our alternative hypothesis, but with some caution, because you don't immediately say that, oh, A causes B. At that point, you need to now revise or come up with new experiments, new observational testing, and you probably want to replicate your findings as well before you just start jumping to conclusions, but it's still a good sign. Okay, we'll start there. Next, we will start talking about the t-test specifically and what it is. We'll describe it, get to know it a little bit, and see some of the different kinds of t-test characteristics. I'll see you then.